All right, welcome to Linear Programming, Day 2. This is taking some of the things we did in 3-4 and just giving you some more examples. Here we have a tax firm deduction, and it needs to determine the clientele it's going to seek for the upcoming tax season. It provides a basic return and an in-depth return. The firm charges $50 for a basic tax return and $150 for an in-depth return. And so we have to figure out the what we're going to use for our variables, or what's going to be what. And so we're going to say that X is the number of basic returns, okay, and Y is the number of in-depth returns. Okay. So, and then we want the profit statement. Write an equation for the total amount of revenue they're going to make from these two type of returns. So their profit is going to be $50 times the number of basic returns plus $150 times the number of in-depth returns. Okay, try to make that D look a little better. Okay. Now, our constraints. What do they need to operate under? The basic return requires 0.5 hours of prep time, and the in-depth return requires 2 hours. And the office has, again, limitations might be personnel, computers, whatever. 700 hours of prep time available in a week. So you have 0.5 for every basic return plus 2 hours for every in-depth return, and you've got 700 hours available. And then you have to figure out the inequality. Well, just like we did yesterday, if they have 700 available, they can't go over that. They can go under it or be equal to it. So it's less than or equal to. Now we need to figure out our x and y intercept. So that in the x-intercept, y is equal to 0, so you have 0.5x equals 700. And when you divide by 0.5, that's like dividing by a half, it doubles the quantity. So your x-intercept is at 1400, which will be 1400 and 0. Okay. Now the y-intercept is going to be 2y equals 700. All right, and so the y-intercept will be found at 350. So that point will be 0, 350. Okay. Now on to our next constraint. The basic return requires 0.6 hours of review time. So the basic return requires 0.6 hours review time, and in-depth return requires 1.2 hours of review time. The office has, at most, 510 hours of review time available per week. Well, at most is really just saying, still, it can be less than that, but it can't be more than that. So that inequality is going to be 0.6x plus 1.2y, and you can see the numbers in this are a little more difficult than the ones we did yesterday. Okay? So 0.6x equals 510 in order to find the x-intercept, so x is equal to 850. And if you need to pause and do this math, go right ahead. So then our point is 850, 0. And our y-intercept will be at 1.2, y equals 510. Let me go back. 0.2y equals 510. So when I divide by 1.2, Okay, so when I find the y-intercept, then the y-intercept is at 425. Okay, and so that point will be 0, 425. Alright, so now we have some more. The office has to provide or must provide at least 100 of each type of return. Well, that means it can provide more. So x must be greater than or equal to 100, and y must also be greater than or equal to 100. So with this page, we have defined all the constraints based on the situation given to us in the problem. What do we do with those? Well, we have to graph them. So let's go on to our next page and graph these. All right, we need to find, we'll count by 100s on this bottom. So we've got, I'll just put, this is 200, and this is 400, 600, 800, 1,000, and 1,200 and 1,400. So our first x-intercept was here at 1,400, and we can count. We can use a different scale on the y-axis because we don't go up as high. So I'll count by 50s. So this is 100, 200, 300, 400, and 500. Okay, and our first y-intercept was 350, so that'll be right there. Okay, now I need to draw a line. Okay, going through that point. Let's see, wait a minute. I want to make it a solid line instead of a dotted line. We want to go right through those points. Okay, so that's our first line. We also have our second line has an x-intercept of 850. So that would be halfway between 8 and 9 right here. Okay. And it has a y-intercept of 425. So that's halfway between 4 and 450. Okay, and then we need to draw that line. Put that line on there. Right there. Okay. And then we have points at, or lines at 100. Okay, which is going to be this line here. Okay. And at 100 in this direction, whoops, do that. 100 in this direction starts here. Okay. All right. So, where is our feasible region? Our feasible region then is this piece right in here. Okay. Oops. Didn't mean to knock all that off. I'm trying to get this little extra shading out from the outside. Okay, so that's our feasible region. We have to find corners. Well, the corners are not too bad to find. This one right here, okay, is going to be at 100 and 325. Okay. And then this one right here is at 100 in the y direction. Okay, and then we need to probably calculate using equation C. Okay, using equation C, if we have 100 in the y direction, we know that from the line we have 0.6x plus 1.2 times 100 equals 510. 0.6x equal or plus 120 equals 510. 0.6x equals 390, and so x equals 650. Now again, you could put those in and you could get an intersection if you want to use your calculator, but that's 650 right there. Now the other one that you're going to have to try to get is this point right here, that intersection, and that's between the two sloping lines, and so we get those equations and we solve using substitution or elimination. So we have 0.5x plus 2y equals 700, and then 0.6x plus 1.2y equals 510. If we multiply this one by negative 0.6, okay, we're going to have minus 0.3x minus 1.2y equals negative 420. Then you add them together, and so you end up with 0.3x equals 90. And so x equals 300. Then you plug it back in for y. 0.5 times 300 plus 2y equals 700. And so 150 plus 2y. Go ahead and solve it out. Okay. So subtract 150 across. 2y is equal to 550. So y is equal to 275. So some of those yesterday, were pretty easy to read on the graph. These not so much. So this middle point is 300 and 275. Okay, so now we've got our 3 points. We've got to put them in the objective quantity. And so you would go through and put them in P equals 50x plus 150y, and you're going to put 100, 325 in as 1, and you're going to put 300, 275, and 650, 100, and there's one corner in the bottom at 100, 100 that I didn't put on the graph. And if you're not sure, that's down here at this point right there. That's the 100, 100. Okay, so we plug these in, and for this one, I'm not going to show the work. I think you know how to do this. We get 53,750. For the next one, we get 56,250. And for the last one, or that one, you get 47,500. And for the 100, 100, you get 20,000. So the maximum profit is realized right here, and that is, if you go down here, they should provide 300 basic returns and 275 in-depth returns to maximize their profit. All right, the rest of the time I want you to work on your homework and try to get that finished.